Okay, here we go. It should be Tuesday the 24th. If it's not Tuesday the 24th for you, then you're probably watching this on the wrong day, or you're late, or you missed class, or whatever the case may be. But don't do that to me. All right, good. Anyway, good to see you guys again. Here we go. We're going to finish up with the engine blocks a little bit here and just talk about a couple of continuing our review. Okay, and so the worksheet that you have now next question should be, what are some examples of different engine sizes and how do they determine that? Well, let's do a quick review first off of the different engine configurations. You remember that? There are three types of engine configurations. There are three types. Do you remember what those are? Okay. One, most common, which is inline. Okay. All right. That means that the cylinders are all in a line. 1, 2, 3, 4, for example. They're in a straight line. That's an inline. The second most common is a V shape. All right, so the engine is actually designed in a V shape. Crankshaft is down here in the bottom of the engine block in the very middle. Then you have the connecting rods and the pistons that go up to the sides. And the engine is in a V shape. That's where it gets its name. And that is the V type of engine. And then the third style, or the third common, is what they call a flat or pancake. And that's where the engine is flat like this. Crankshaft is right in the middle. Connecting rods and the pistons will come out to the side, such as this. And so the motor or the engine block is flat, and this is a pancake style of motor. Okay? All right. So now to that very first question is, what are some of the different engine sizes and how do they determine that? Okay? So if we remember right, the engine sizes, everything is measured now or noted now in liters, correct? Right, and so some of those engine sizes might be a 2.0 liter, 2.3 liter, 4.0 liter, 5.4 liter, 5.7 liter, 6.2 liter. Okay, and those engine sizes are greatly affected by, or they're determining what the engine size is. And how do they determine that? If you remember, we talked about that before the break. And the engine size is determined by a couple of different factors. Obviously, one is the number of cylinders. Okay, so in other words, the more cylinders you have, the larger the motor is, number one. And number two, the size of the cylinders. Okay, so that's the other thing that they use to determine the size of the engine. So what is the equation, or what is those factors that they use to determine the engine size? Well, we talked about that before. What they're doing is we are taking the engine or the cylinder size. We need to find the area of a cylinder. So what we do is we take the area of cylinder, okay? And the area of the cylinder is determined how? Well, it's measurement from top dead center minus bottom dead center. Okay, so we get the height. Oh, let me back up. So the way that they determine it, the area of the cylinder, is they're taking the area, I guess that's what I should put, the area of cylinder from BDC. You remember what that means? Bottom dead center, where the piston is at the very bottom, to TDC, which is, yep, top dead center. Very good. See, you guys are sharp. That's why I like you guys. You guys are the sharpest around. Okay, so the area of the cylinder from bottom dead center to top dead center. The way that we do that is we have to take pi 3.14 times the radius squared. Okay, times the height times number of cylinders equals engine size. So that's how we're determining our engine size. So obviously, since we have to determine the number of the cylinders is in the equation and the size of the cylinders, right? The area of the cylinder, I'm going to put over here area of cylinder. The larger the area, obviously, the bigger the engine size. So that's how we determine the engines, or the engine sizes are determined, right? Okay. So next question on our worksheet is, what are pistons? What are pistons? Okay. Now pistons are cylinder shaped parts, cylinder shaped parts that fit inside cylinder. The piston obviously does all of the work of the power of the engine, or the explosion, the compression, and the power stroke. So the piston fits tight inside the cylinder, okay, and then travels up and down. Okay. What are the connecting rods and where are they located is the next question. Connecting rods. We talked a little bit about that yesterday. What are the connecting rods? They're a component that attaches the piston to the crankshaft. Right? Connecting rods. Connect piston to crankshaft. You'll find the connecting rods located down in the engine block area, obviously, because it houses the pistons and the crankshaft as well. So obviously, the connecting rods will be located in the crankshaft. Okay? The next question is a two-part question. What do main bearings and rod bearings look like, and how are they protected? Now, we talked briefly yesterday about main bearings, okay? And so, again, what do the main bearings look like? Well, they're a thin piece of metal, okay? They're a thin piece of metal made out of, they're an alloy metal, which alloy means that they're made out of multiple different types of metal. And they go in between, again, the crankshaft and the engine block, where they're mounted together. Connecting rod bearings do the same thing. Connecting rod bearings will go in between the connecting rod and the crankshaft in the connecting rod journals of the crankshaft. Remember, we talked about main bearing journals. That's the area where the crankshaft is mounted to the engine block. The connecting rod journals is the area that the connecting rods are mounted to the crankshaft. That's the area that the connecting rod bearings go. Now, the second part of that question is, how are the bearings protected? Well, we should know from last year that the product that protects our motors from friction is engine oil. And so the way that the connecting rod and the main bearings, the main bearings and connecting rod bearings are protected is with lubrication from the engine oil, and that engine oil is forced in between the main bearing and the crankshaft. So if we draw a little bit of a picture, let me see if I can get a good picture for you to help you understand just a little bit better. So we'll say as example that this is our crankshaft. In between the crankshaft, the next part that is in place here is our connecting rod or main bearings. That's this component here, main bearings. And then outside of that, we will have the housing, either the engine block or the connecting rod that is attached, or that the crankshaft is mounted to. So we will have the caps here. So I'm drawing lots of extra space, and so this will be a bolt that will mount here. Okay, one bolt there. I'll have a bolt that comes through here. That's not a very good picture, but you guys should be used to my artwork by this point. So it's right in this area here. I wish I had a different color pen. Hang on, I'll go get a different color. Okay, so we'll say that the black part, we'll draw our main bearing here in red. Well, this isn't a very good pen. Just go get a brand new pen and it's not very good. Okay, hopefully you guys can see that. There's my main bearing. We have my crankshaft in the middle, my engine block and main cap here, and then the oil is forced in between it's actually not in there. Take that back. The oil is forced in between the main bearing and the crankshaft, since this is where the movement is. There's no movement out here where the main bearing cap attaches to the it's housing or help holding the bearing. Okay, and so the bearing doesn't move. And so our friction or our lubrication comes from the fact that the oil is in between the main bearing and the crankshaft. And so that oil is what creates the cushion there and prevents those two pieces of metal from coming in contact with each other. So good oil pressure and good lubrication is critically important to the longevity of a motor. But that's why we can have a bearing that's made out of metal, thin piece of metal, that is actually housing the two pieces of metal. There's no rollers or any kind of rollers or bearings or ball bearings or anything to create or allow that movement. It's simply a film of oil that keeps those two, the bearing and the crankshaft, from coming in contact with each other, and that's what keeps the engine lubricated and the bearings protected, as well as the crankshaft and other components. Okay, what is bearing clearance? Well, as we just got done drawing this picture of crankshaft main bearings, bearing clearance is the amount of space between the bearing and the crankshaft. That is space that belongs in there. Okay? That way that the oil can be forced into that gap, so there must be a space here. It can't be completely tight. And so that's what we call bearing clearance. And there are specifications for bearing clearance, and that will be part of your assignment coming up in the next few days, is to look up the different bearing clearance on some different engines. And you'll find that the bearing clearance is very, very tight. It's very, very close, and therefore the oil has to be very, very thin to be able to get in between those two surfaces and protect them from each other. Just so you can, I want you thinking about what bearing clearance is and how much space that really is. And it's really critically important that this be a tight tolerance, but not so tight that oil can't get in there. Otherwise, the engine will fail because it can't be lubricated. Okay? And the last question is regarding piston rings. Okay? So pistons have piston rings. So how many piston rings does a piston have, and what do they do? Okay? Well, if you guys remember before the break, we determined that there are 3 piston rings. 3 of them. And what do those piston rings do? Well, the one on the very bottom, the bottom piston ring, is quite thick in diameter, and that is our oil ring, as we talked about before. So if we take a look here on our engine here, you can see on these pistons that this bottom ring right here is quite a bit thicker. And that is an oil ring, and its job is to, if you remember right, we talked about squeegeeing the oil that gets sloshed up on the inside of the cylinder wall here. And so as the engine is spinning around and cranking, the oil is being slung off of the crankshaft, getting onto the cylinder walls, and that oil ring right there is designed to squeegee that oil off so that the oil stays in the motor and continues to lubricate. The other 2, so let me put on here, the bottom one is the oil ring. Okay, the top 2 piston rings are, if you remember right, those are compression rings. Okay, and the compression rings are designed to keep the compression, or that combustion process that's happening inside the cylinder. It's designed to keep that pressure up in the very top of the cylinder. Okay, one, it needs to be a tight seal so that when the piston comes up to compress the product, the fuel mixture, that it can compress it, that it's a tight seal and compresses that process. And then when the combustion process happens and we create that explosion in here, that it will seal and hold that pressure inside here and allows it to push down on the piston, and therefore we have rotation. Why are there 2 piston rings? Why are there 2 compression rings? Well, we talked about before, you remember that the compression rings have a split in them. And what's that split designed there for? Well, it's twofold. One, the piston needs to be compressed because the piston is expanded larger than the cylinder opening. Okay? So therefore, you compress the piston ring to squeeze it so that it will fit down inside the cylinder area. And then because it has tension on it, wants to widen out, the outer edge of the piston ring then will seal against the cylinder wall and keep a tight seal. Now, there has to be a split so that you can service the piston ring. In other words, we need to be able to get it in and out of the cylinder, and it's got to have some spring tension on it. But that gap will leave a compression leak. So all pistons will have 2 compression rings, both with a split in it, but when they're installed on the piston, they will be staggered as far as their split goes. So when you put them on top of each other, now you've got a complete circle or a tight seal that fits all the way around the piston and maintains good compression. So we do not want the combustion process 1 to leak past those piston rings down into the engine. That means that the piston rings have worn or the cylinder walls have worn. Number one, creates some coking and some problems with the engine oil, as well as a loss of horsepower because we're not maintaining that pressure inside the cylinder wall there, or inside the cylinder area. So that is just a brief overview of piston rings as we talked about before the break. So if you guys will do that worksheet, and I will have a new video and a new lesson for you tomorrow. It's good to see you guys. Thanks for watching, or thanks for coming to class. Make sure you get that assignment turned in so that I can give you credit. We are still doing grades, progress reports, so on and so forth, so that you seniors certainly can graduate, number one, and number two, I know that you guys understand the information that I'm giving. Give me some feedback as well on these videos. Maybe I can help you just a little bit more. And thank you guys. I'll see you tomorrow. Don't forget to wash your hands. See ya.